Variables are named storage locations used for storing values. We can use variables in place of raw values within our code. This makes our code more readable and at times more efficient. Let's have a look at the topics covered in this lesson. We will start with a practical introduction to data variables, constants, and object variables by doing some hands-on coding. Our focus for the remainder of the video will be on data variables. We'll cover constants and object variables in upcoming videos. Next, we will cover the various coding statements required to use variables within our code. And then, we will discuss the 4 major properties of a variable. These are the variable name, data type, data value, and scope. Great. Let's dive straight into the topic with a practical example. Data manipulation is at the heart of VBA. As a VBA programmer, we are bound to find ourselves interacting with a variety of data values within our code. Check out this print statement. We are grabbing a value from cell C6 and printing it out along with some fixed text. This fixed text is called a hard-coded value or a literal value. Let's run the macro and we get the text Robert has been approved a home loan. But what exactly does this value in cell C6 represent? Looking at the output, we can guess that we have grabbed the first name of a person from the worksheet. We can even go to the worksheet and check out what value is residing in cell C6. But as a programmer, we shouldn't have to guess or keep checking the worksheet. In fact, let's make this code a bit more complicated to stress this point. And now we've added a condition. If the value in cell E6 is greater than 500, then and only then we will approve the loan for the customer. But what is this new E6 value? And imagine 10 more lines like this. Our code would get more difficult to read and we ourselves would struggle to follow the logic contained within our own code. As a solution, suppose that we are able to use a meaningful label in place of these actual values. Let's see what that looks like. What we are doing here is now providing a label for each of these cell values. We'll take the value in cell C6 and store it in a label called customer name. And the value from cell E6 will be stored in a label called credit score. And now we can use these labels within our code instead of the value itself. So we can replace this with the label credit score and customer name in place of the cell C6 value. Now look at the if and print statements. The logic here is clear to us. If the credit score is greater than 500, then print out a message stating that the customer, whose name is proxied by the customer name label, has been approved a home loan. These labels are called variables. The value assigned to a variable may be of any data type, such as a number or a text. A variable is stored in memory. Hence, the data type that we assign to the variable will affect the usage of memory and the speed of our code execution. And as the name suggests, the value stored inside a variable is, well, variable. In other words, it can be modified. We can assign one value to a variable and later on in our code, we can change it to something else. Let's see an example. We will grab the preferred name for the customer from cell C7. If a customer has a preferred name, we will use that name to refer to them instead of the first name. So if there is a preferred name, then we will change the value held within the customer name variable to equal to the preferred name instead. So now the customer name will equal to the preferred name. So basically we're assigning the value on the right side of the equation to the variable on the left side. So now when we run the macro, the print statement will give the preferred name instead of the original first name. Let's run this macro. And we get Bob has been approved a home loan. So what happened here was first the customer name was assigned the first name Robert from cell C6, but since there's a preferred name present as well in cell C7, the value stored in customer name was switched or changed to the preferred name. And if we want to use a label for a value that we know is not going to change, we could use a constant. For example, this value 500 is not going to change. instead of using the raw value within our code, we can assign it to a constant. We'll do that on top. And now we can use this constant in place of the actual value. Test the macro, it works. And lastly, we have object variables, which refer to objects within the object model. For example, we can create an object variable to represent the sheet home loan, which is a worksheet object. Let's do that. So the object variable ws home loan references the sheet home loan, and now we can use this object variable in place of the worksheet path within our code. And look at that. Variables have made our code more manageable and easy to read. And our appreciation for variables will only increase as the complexity of the coding logic increases. In this video lesson, we will deep dive into data variables. In this exercise, we will first complete the task of creating a variable and then revisit the significance of each part of the code systematically. We can start by announcing the existence of a variable to VBA. Let's create a variable to hold a product name for us. We will use the keyword dim to declare variables. We need to give the variable a meaningful name. And we can define the data type using the as clause. And since we plan to hold a text value within the variable name, we can use the string data type. Let's assign this variable a value. To assign a value to a variable, we will use the assignment operator, which is the equal to sign. We'll hold the name chocolate muffin within the variable, which is a text value, which is called a string in VBA, and strings need to be entered within double quotes. And finally, let's print out the value that is stored in the variable. And note that when we are using the variable within our code, we refer to it directly and not within double quotes, even though it's holding a text value. Let's run the code, F5, and the value from the variable gets printed into the immediate window. Now let's understand the mechanics behind this coding logic. We have 3 lines of code, each of which is doing something with the variable product name. Each of these lines is called a statement. A code statement in VBA is a complete set of instructions. Let's look at the code that we've just created. The first line is a declaration statement where we're declaring or announcing the existence of the variable to VBA by stating its name and type. The next line is an assignment statement where we assign a value to our variable. In a broader scope, an assignment statement is where we take the value on the right side of the assignment operator, which is the equal to sign, and store it in the element on the left side, which in our case is a variable. And the third line is an executable statement, which initiates the action of printing out the value stored in the variable. In general terms, an executable statement performs an action. Okay, so now we have a general idea of the coding logic through which we create and consume variables. Next, let's discuss the 4 major properties of a variable, which are name, type, value, and scope. Let's look at how to name variables. There are some VBA rules for naming the variable, and these are the same rules for naming sub-procedure names as well. You must use a letter as the first character. You can't use a space, period, exclamation mark, or some special characters in the name. The name can't exceed 255 characters in length. We can't use reserved keywords such as sub and end, and we can't repeat names within the same level or scope. For example, we can't have 2 variables with the same name in the same sub-procedure. Besides these mandatory rules, there are some suggestions. Try and assign meaningful names. So instead of using alphabets such as A or L or non-relevant names such as var1, var2, using a more relevant name such as product name, as it tells us, the developer, what information is stored in the variable. To separate 2 words in a variable, we can use underscore or camel case. We can prefix the variable name with an abbreviation that indicates the data type. For example, adding str in front of product name, where str represents string or text data. This style is called Hungarian notation. It's a good practice, but not necessary. And don't shy away from using long names. We don't need to retype the names each time we use them in our code. Once a variable is declared, the variable will be available in the IntelliSense list. So let's come back to our code. We want to type the variable name product name, which has already been declared on top. Press Ctrl plus J on the keyboard to bring up the IntelliSense list, and we can scroll down or start typing a name and tab to accept the selection. Alternatively, you can start typing out the variable name and press Ctrl space to autocomplete. I personally prefer to double click on the variable name, press Ctrl C and paste it in the new location. Type refers to the kind of information that is stored in the variable. When we declare a variable, we need to specify its name and characteristics of the value that is intended to be stored in the variable. These characteristics are its data type, and we have a variety of data types to choose from. The following list shows the popular data types available in VBA. We have numbers, strings, which are text values, boolean, which is true or false, and even variant, which can store any of the above types. And just to be specific, a numerical value could be a byte, integer, long, double, or even a variant. Each data type can hold a range of values as seen in column 2. For example, a byte can hold a whole number from 0 to 255. Programming in VBA requires planning for dynamic data. So suppose we want to perform some action over each row in the following data set. Right now, this data set has 300 rows excluding the header. But the assumption is that the rows in the dataset may change each time we want to run a macro. So tomorrow, the user may want to run the code over a dataset with 15,000 rows. As a programmer, we need to factor this in. Consider the following code. We need to find the last row of the dataset so that we can loop over it. And this last row variable represents the potential number of rows in our dataset. We can ignore the rest of the code. The question though is, what data type would we use for this variable? If we are reasonably certain that the rows will never exceed, say, 100 rows, we could use a byte data type, which can hold a value of up to 255. But if we want to leave the choice to be completely dynamic, we can use the long data type, which can hold a value of up to 2 million, which is larger than the maximum rows allowed in Excel. Now consider this. What if we insist on declaring this last row variable as a byte, knowing that the dataset has 300 rows? Let's run this code. We get a runtime error with an overflow message, which basically means we're trying to pass in a larger value into the variable than the maximum limit allowed by that data type. So the current value that we are trying to pass in through the variable is overflowing the data type's maximum limit. And what if we chose not to specify any data type? So like this, where it's just dim last row. In this case, VBA will assign the default data type, which is a variant, which can hold text, numbers, etc. We can even declare multiple variables in a single dim statement. So here, we are using a single dim keyword, but the data type for each variable is specified separately. And look at this next declaration statement. If we were to specify the data type only once, then that data type would only be applied to the last variable. So in this case, only the first row variable gets declared as long, and the first variable will be allocated to the variant data type. So be careful of that. The value that we pass into a variable will be stored in the computer's memory. And when we declare a variable, VBA reserves some memory space depending on the data type that is chosen. Column 3 shows how much space each data type consumes in bytes. So as a programmer, we need to find the balance between consuming the smallest number of bytes, but at the same time covering off our maximum requirements. Hence, we should always declare the data types for our variables rather than let VBA default to variant, which consumes the maximum amount of memory. Let's look at the dim keyword. It initiates the declaration of a variable. It is not compulsory to declare variables, but it is good practice to do so. In this code, we are forcing the explicit declaration of all variables by mentioning the option explicit statement right at the top of the module. Every new module for me will have the statement on top, which is governed by a setting in Tools, Options, and the require variable declaration setting, which is ticked. Okay. So if we try to run this macro without declaring the last row variable, we will get a compile time error telling us that a variable has not been defined. Let's run it. Okay. And the first undeclared variable is highlighted. This check is good because it avoids spelling mistakes. For example, let's remove this option explicit statement and misspell the variable in the print statement and run the macro. Nothing gets printed out. And let's leave this incorrect spelling, but this time with all our proper code. So put in the option explicit statement, declare the last row variable, and run the macro. And the misspelled variable is immediately pointed out for us. This is a simple example, but in larger, more complex code, spelling mistakes are difficult to spot. Hence, it is always advisable to have this option explicit statement right on top, which basically means we should always declare all our variables. Next, let's talk about where to put our dim statements within our macro. Microsoft documentation recommends that we put them at the beginning of a procedure, like how I've done out here. Another way is to declare variables right before you need them. And this is what I follow in practice. So I'll show you what I mean. We're going to first use the worksheet object variable. So I'll leave the declaration for the worksheet variable on top, remove the declarations for the string variables, and place them right before we are about to use them. So here we declare the string variables for each of the cell values, and here we assign those cell values to each of the variables. But in this VBA course, I will switch between both styles depending on the context. Let's go back to the way it was. Declaring variables at the beginning of the macro does create one issue. In procedures which run into several lines, it will get tough to determine what the data type for a variable was supposed to be. So for example, let's come down here to the if statement, and suppose we want to understand what the data type for this credit score variable is. What we can do is press Shift F2 and it takes us right up to the declaration statement, and we know it's a string variable. And we can press Ctrl Shift F2 to go back to the line that we were on. Let's look at our code statements again. A variable is given a default value when it's declared in the declaration statement. This is called initialization. And in the assignment statements, we actually change the value of the variable from the default to a new value. Let's look at a data type summary table. Column 4 in the data type table shows the default value of each data type. Every numeric data type defaults to 0. The default value of a Boolean variable is false. A string defaults to a 0 length or blank string. Variant variables default to empty, and object variables default to nothing. And on a side note, empty, nothing, and for that matter, null all have different meanings. We will touch on this in the lesson on data types. So let's see this in action. To observe the default value and the assigned value for each variable, we can bring up the locals window. So view, locals. Let's step through our macro. So press F8. So on our first F8 stroke, VBA scans through the macro code and populates all the declared variables in the locals window along with their types and the default values. So we can see the first 3 are string variables and they have a value of blank, which is basically 2 double quotes, and the worksheet object variable defaults to nothing. Let's step through our code. F8, we are on the assignment statement for the worksheet variable. F8, and now the worksheet variable has been assigned a valid object reference. It is referencing sheet 1, which is the code name for our home loan worksheet. And F8 over the assignment statements for the string variables, and we can see each of them populates with their respective text values. Let's talk about scope and lifetime of variables. Scope tells us where a variable can be accessed from, and lifetime tells us for how long can we access the value within that variable. Let's revisit the subprocedure from earlier where we find a last row within a data set. To recap, first we declare the last row variable, then we assign it a value, and finally we execute the print statement to output the value held within the last row variable. Using the dim keyword within a procedure signifies that we can only use this variable within the current procedure. This means it's a local variable and its scope is restricted to the procedure in which it was declared. So we can't access the same variable from outside this sub. To test this, let's create another sub that prints out the last row variable again. And let's change the first sub name to find last row. Let's run the first sub. We get our last row value. And let's try and run the second sub. We get a compile error stating that the variable is not defined. This is because the last row variable from the first sub is out of scope. In other words, the last row variable from the first last row sub isn't visible from within the second print last row sub. So a local variable can only be accessed from within the procedure in which it was declared. There are two types of local variables. When we use the dim keyword within a sub, the local variable will retain its value as long as the procedure is running. When the procedure stops, the variable will lose its value. This is its lifetime. We can even use the static keyword to declare a local variable within a sub. Let's do that. This is not as common, but with static, we can preserve the value of a local variable even after the sub has stopped running. Let's add another print statement right after we declare the variable. At this stage, the variable which has a long data type will have the initial value of 0, and the second print statement will output the actual last row value. Let's run the code. We get 0 and 301 as expected. Let's clear the output. Observe what happens when we run the macro again. Play. We get 301 and again 301. So how did we get this first 301, which was printed out by this first print statement? This is because the value within the static variable was preserved or saved from the previous macro run. Next, if we want a variable to be accessible from another procedure within the same module, we would need to declare it as a private module level variable. First, let's modify our two subs, change this back to dim, remove both the print statements. So the intention here is that the first macro will simply find the last row value, and the second macro will print out the value of the last row that was found in this previous sub. But since this last row variable is declared as a local variable, we already know that the second sub will throw a compile error. To allow both subs to access the same last row variable, we need to declare it at the top of the module. Let's remove the dim statement from the first sub, make some space, and paste it at the top of the module before we begin any procedures. Here we can use the dim keyword or the private keyword, but using private makes things more clear. Now let's run the first sub. There was no variable declaration in this first sub, yet it ran without error. Now let's run the second sub, and it printed out the value that was assigned to it in the first sub, which means that the value within the variable was preserved between calls as well. So this was an example of a private module level variable. Let's move this print last row sub to a different module and let's run it. We get a compile error. The private declaration for the last row variable, so up here, meant that it could only be accessed anywhere from within the same module, which for us is module 4. To make it visible to a procedure sitting in another module, we need to change the declaration to a public module wide variable or a public variable. For that, we will use the public keyword. Let's run this first sub again. Now let's go to module 3 where we have our second sub and let's run it. No error and the value gets printed out. Static, private and public variables consume memory resources even when the code is not running. Hence, we should try and avoid using them unless absolutely necessary. If the intention is to simply pass the value of a variable from one sub to another, we could use procedures with arguments or functions to return values. We will check out these topics in upcoming lessons. Variables are named values stored in memory. Usually we declare a variable using the dim statement. Try and declare data types for each variable where possible, otherwise they will default to the variant type. Scope of a variable determines where it can be used within the same procedure, within the same module, or across all procedures and modules. And that was an introduction to variables. In this lesson, we focused on data variables that hold values such as numbers and texts. In the next lessons, we will cover constants, which are simply variables that can't change values, and object variables.